Hello and welcome. My name is Anita Schmid. I'm head of marketing analytics at Micro, and I will be your host for track 4 today. First, we welcome Carina Mieth. Carina Mieth is working in research and development at Trumpf Machine Tools. She's using data and artificial intelligence to make products and services for the sheet metal industry more sustainable and energy efficient. This presentation will provide an overview on the various areas in which data and AI solutions will pave the way to sustainable manufacturing. Welcome.
Thank you. Hello, everyone. My background is in electrical engineering, and I transitioned to the manufacturing industry and worked on several data analytics and AI projects. And in the recent year, the topic of sustainability became more and more important. And in today's talk, I want to focus on how data and AI can be used for the resource efficiency in manufacturing. For example, how you can use it to decrease the amount of carbon dioxide that certain applications emit, and also other resources like material, gas, and so on. And to make clear where we are in this talk and what is the domain, I want to give a short introduction to the manufacturing systems that we are looking at. So the sheet metal processing is a discrete manufacturing environment where you start with a blank metal sheet and you cut parts out of it, bend it, and later you can also weld it to produce different products. And Trumpf as a company started some years ago to develop certain or different AI solutions in every of these different domains. And today I just picked out some of them which are paving the way to more sustainability in manufacturing. And let's get into the topic by looking also at what are these products and where does the carbon footprint come from. So basically we have products that are everywhere. So from the automotive industry where you have battery boxes where the batteries are embedded safely, and also in the consumer electronics area or for server cabinets. So there is a great variety. And on this slide, it's important that you take away that these sheet metal parts are in their carbon footprint like 10 times higher compared to the production energy that is needed to produce these products. And this is important because if you focus on material efficiency with data and AI solutions, you have a very high impact, but also it's important to have efficient machines, of course. So why should we focus on the industry when we think about how we can implement AI solutions for good? So the industry is contributing to 1/4 of the overall energy-related carbon dioxide emissions, and the iron and steel sector emits 7.2% of it. So it's quite a percentage, and if you then look at the possibilities that come with digitalization and data, it is estimated that up to 58% of the climate target that we have for 2030 can be achieved through accelerated digitalization and the use of AI in the industry. And for the production, which is a subpart of it, we have the potential of 23%. So a lot of potential lies here, but we have to exploit it. And this is part of this talk. And why is it important to look at the industry and not looking at other sectors, for example? It's for me personally that I want to have an impact with my work, and I have a little example for you why it's important to not focus on maybe more your individual choices, but go to the industry and have the big levers. So for me personally, the carbon footprint for a German citizen is about 11 tons of carbon dioxide. And my life expectancy is 83 years. On average, for women, it is like this. So my life will amount to 930 tons of carbon dioxide. And 2020, I decided to go vegan to save 1 ton of carbon dioxide. So this was very ambitious, and I thought it's good to do that. So overall, I will save 55 tons of carbon dioxide. So last year I led the climate strategy in the machine tool department in Trumpf, and we identified reduction potentials of 410,000 tons of carbon dioxide. And you see, it's not important what you do on the personal level, but it's way important to go to the industry and apply your data science and AI knowledge there, because then you have a big lever. And yeah, so that's my first takeaway here. And when I started to prepare this talk, I did a lot of research about sustainable AI. And what was interesting for me is to know what people think of first, because you can either think of sustainability of AI and other AI for sustainability. And then I tried to make a poll on LinkedIn, so it was the first time I tried out this feature. And as you can see, 70% think there's of AI for sustainability. And I don't know if that's surprisingly for you or not, but yeah, I also read a paper by Amy van Winsberg, and she also said that the AI for sustainability is currently more prominently researched, and the sustainable AI aspect is something that we also have to look into. So, but yeah, in my case, since we're in the industry and I want to be on the big lever, we will focus on the AI for sustainability case here. But later I'm excited to discuss also how you think about this figure here. And when I speak about sustainability, there are three aspects always to sustainability. You have the ecological dimension, the economical dimension, and the social dimension. And for a manufacturing company, of course, it's important to first look at the ecological dimension, or in general, it's first important to have the ecological dimension straight, because otherwise you can't build stable societies if the ecological system is destroyed. And then later on, the economic is the third thing you have to consider. And when I talk about AI, I mean weak AI. So overall, we will now look into examples how we can use AI to have a more efficient use of energy and resources with the help of weak AI. And what's the current status? I researched it a little bit, and there's a really great study from the German Association of Engineers that were interviewing companies in Germany on their motivation for using AI in projects. And they compared in implemented AI projects what was the reason why they implemented AI into it. And of course, cost savings, time savings, or having a competitive advantage was one of the main reasons why they used AI. And it was not that important for them right now to look at energy, material, or carbon dioxide savings. But then they also asked, how do you plan to look at other reasons why you want to use AI in the future? And you see that the figures nearly double in the area that is related to sustainability. So there's a lot of traction in the field, and therefore we are now looking into how we can leverage the potential along the manufacturing value chain. And I divided this in four parts now for the remainder of this talk. And the first is the product design and development part. And there we have, and after the procurement and supply chain part, the production part, and the circularity and transparency part. And for each, we have several examples, and there's not enough time. I will also only present one in each category, but I have prepared more, and if you're interested, just come to me afterwards and we can discuss, and maybe also you have some applications there. So in the first column, we can use AI for the enhanced product design and also to develop new materials or catalysts that pay into the sustainability aspect. And the example I brought to you is in the first category, and it's from a startup that Trumpf founded. It's called Optimate, and Optimate is a software that optimizes constructed parts. So if you have a CAD data file of the part that you want to produce, you can upload it to the system, and the system identifies flaws in the design and recommends how you can change it. And currently you can estimate, for example, if you undercut the flange length, this is then not producible on a bending machine, and then the design is changed and the length is extended. And also if you have little holes near the bending zone, this can lead to deformation. And to avoid this, the design introduces then little slits that release the strain on the bending zone. And the most difficult part in this process is to identify process steps that are very cost intensive. So in this part, on the left side, you have a welding process. And if you are familiar with this part, you see that you have to first cut, then to weld, and the third step here is to weld. And with this design on the right side, you can avoid doing the welding process, which leads to a lot of cost savings. I don't know why it's always pushing one before, so sorry. So you can save the step by introducing other bending design here, and then you can just mount the part together with screws, which saves you a lot of time and money and energy, because you can just leave out the welding process here. And other examples showed if you, for example, change a part from milling as a production process to sheet metal processing, you can also save up to 85% of the costs of the part and 69% of the carbon dioxide footprint that comes with it. So there's a huge potential if you optimize your part design. So the next part is about the supply chains and the procurement. One important factor is that you can build recommendation systems into your procurement processes at the company, so that you always direct your purchasers to low GHG options, for example. Other topics are that you can optimize your supply chains and, for example, try to out or insource certain parts in capacity marketplaces, which is a good thing to either increase the utilization of your own machines or to avoid buying a new machine that you might not use to a full extent and which would then just stand around idle, wasting energy and resources. And the example I want to show you is a little small example, but it's in the demand forecasting area. Trumpf developed an app which is in the spare parts reordering, and this app includes an AI that identifies the spare part by making a photo, and then the parts can be ordered automatically. And by this we also get good data about when parts fail, after which time, at which customer, and we can also analyze over time how there are maybe seasonalities or how often we have to reorder our stocks as well. And going to the next part, the production part, there are also a lot of different things that where data and AI can be used. First of all, we will always want to have high quality in the manufacturing of these parts to avoid reproduction of parts, because we already know that the footprint is very high in the sheet metal parts. So it's good to have the improved quality or like optimized control. We can, for example, optimize the machine with respect to the energy usage, which then, for example, switches out certain consumers when they are not needed in the next time. And other topics, which is, for example, very popular, is predictive maintenance, of course. If you know exactly, or you can predict it very good when the next failure might occur, you can steer against it and buy stuff in advance to exchange that and make the okay, I need a word. But then I continue. So we also have the increasing utilization with better planning, or that you, for example, do demand-side management for using your own generated electricity from the PV that you might install on your roof. And then you can match, for example, the production orders that you want to produce with the energy forecast of the PV. So these are the examples here, and what I will show is the improved quality example that we have, which is the sorting guide. And the sorting guide is an assistance system that has a camera installed which looks on the sheet metal part. So the sheet metal parts are cut, and then a worker has to remove the parts from the sheet and has to sort everything for the next processing step. And on this sheet, you normally have orders from several customers. So it's not that easy to just put everything on one trolley. You really have to check papers and decide, okay, how do I manage to put everything through the next process step? And the sorting guide here assists you and shows you where to put things, and it's also putting or booking when you remove the parts. And what we have there is a camera that detects whether the parts are removed, and where the parts are located. And with this, we can increase the utilization of the machine because the worker is faster in removing and sorting the parts, and we also avoid rework because parts are not getting lost. They are just tracked, and we have all the data available when the part was removed and where it was put for the next process step. And how does this work? So the team started working on classic computer vision algorithms first, and we started to collect data, and there was a lot of work done to label everything. So here's an example of a sheet metal plate, and of course you have to label where is the part and which parts are removed. So this was very tedious at the beginning, but later on we had more data and we switched the algorithms to have a better outcome at the end. And now we are working with a neural network instead of the computer vision, and the team is also here in the room. Maybe you can raise your hands. They're down at the Trumpf booth later, so if you're interested in this is very sensitive, I don't know. If you want to talk to them, just go downstairs, they're there. And the next example of AI used in our machines is to improve the control. And this is done at the True Laser Center 7030. That's the most advanced machine that we have. And this machine not only cuts the parts, but it also sorts them and removes them from the sheet. So not the worker has to do it anymore, but the machine does it. And what's difficult here is that we have a variety of geometries that needs to be removed. And you have to program where these pins should be placed under the part and where the shuttles should push from above. And this programming is done automatically beforehand, but sometimes the removal fails. And this machine is so intelligent that it retries again and again until this removal is successful. And from this data and the removals, we learn how we can adapt the position of the pins and shuttles over time. And we learn from all the machines that are out there to improve that the programming is better and better over time. So that's a self-learning machine. And the next and last example is in the realm of circularity and transparency. We can use data along the loops, how you call them in the circular economy, to track, for example, material parts and so on. You can use AI and data science in general to detect where a lot of GHG emissions occur in your production facility and the supply chain. And last but not least, I added equipment as a service here, which is a new business model that Trumpf started 1.5 years ago, approximately. And this is a business model that thinks in a circular and sustainable way by definition. And how does this work? So in the equipment as a service model, the company or we are not selling the machines directly to our customers, but the customer just pays per part that he or she is producing on this machine. And this changed a paradigm, like normally a manufacturer before some years ago, they just sold machine and then they were done with the task. And now we are very incentivized to increase the utilization and the longevity of this machine to have a very reasonable price that we can offer our customers. And this is done via remote operations and the self-improving system that I showed already with the pin and shuttle placement. And we are also launching other applications where we use this improvement cycles to always send out new system updates. And on the material part, you also see that we are continuously pushing new algorithms out there for the increased nesting efficiency, which saves the material. And the energy management and also like the logistics is handled with us. So it's like a closed business model, and the customer can then benefit from having that all managed together and study a system IQ. And our partner Munich Re and Trumpf did together showed that by this business model you have a reduction potential of minus 65% in the carbon dioxide emissions that you produce compared to a normal production scenario. So it's very beneficial, and it comes very natural to shift your focus from I'm not pushing anything, it just goes to the next slide. So it's very natural because if you look at the fleet emissions of a company, you have the number of machines times the resources that they use. And if you want to be sustainable, you have to somehow decrease it. And if your business model relies on selling more and more machines, it's hard to, on the other hand, gain by just making them more efficient. So you have to decide how do you handle that. And if you switch to a business model, which is like the equipment as a service, you not have the problem that by reducing the number of machines, you're not losing your profits. So it's basically the way to go if you want to increase profits and be a successful company in the future, but on the other side also want to be sustainable. Okay, so time out. My call to action maybe, if you're from the industry, accelerate digitalization because you need it as a fundamental to have a sustainable company. Build data ecosystem because otherwise you are not able to get the data from partners that you need, for example, to calculate carbon footprints. And if you're a data scientist, maybe try to also focus more on resource efficiency in the next project because you can oftentimes align resource efficiency with cost savings. And yeah, let's all make an impact or a difference by applying AI and data science in the industry. So that was it. Thanks for having me, and I'm eager for your questions.
Please wait for the microphone because we have people online.
Hello, my name is Kurt Stockinger from ZHW. So I have a question about, you said you have a 65% CO2 reduction. So we had yesterday a workshop with the United Nations environmental program also to show, and the big questions that we had there, how can I prove that you have a 65% reduction? How do you open your supply chains? Do you say, you know, I have this material and this material is produced here? Otherwise, how would I trust you? Or let's say the other way around, how can we incentivize? You say you want to reduce something, it's all great, but do you open your supply chains to give a proof so that I can actually check whether it's not just, you know, greenwashing, that it's a real fact?
Yeah. So yeah, it's a very difficult thing to calculate the product footprint of something because the steel, for example, does not come from us. So we just buy it, and then we rely on the supplier of the steel to give us the numbers on the steel, for example. Then in the next step, our production system has to monitor how much energy and gas we are using in the cutting, bending, and so on. And this amount of data is planned to be included in monitoring solutions so that we are able to give this data out. So of course, then it's calculated by us. That's the case, but if you have a level of transparency that people can see how it was calculated, you have to trust the sensor that is in the machine that is measuring the meter. So maybe that's then also some energy meter that's not even invented by us because we are just buying energy meters and put it in our machines. So maybe then it's the ecosystem that you build around it. And that's what I meant by being open to share data and to think in the whole value chain, because otherwise it's not possible for a manufacturer like us to have the whole transparency, because we can say what we are doing at our part of the game, but as you already heard, the sheet metal footprint is 10 times higher. It's also important to have transparency there. And yeah, we are working with our suppliers and the partners that are in our ecosystem to have this transparency, but it's obviously a way to go. So yeah, working on it.
One more question.
Hello, this is Luca Forer from Trivadis, part of Accenture. Just wondering, because I grew up with operations research, are you also optimizing your cutting patterns that you're utilizing the kind of the sheet at the max, or is this done automatically, or is it done by humans?
This it can be done by humans, but we have algorithms that program the parts on the sheet. But of course, you have certain parameters that are influenced by the humans that are in the production system. For example, you can put different parts from from your production schedule on a sheet that one part is due today and the other is due in 2 weeks. And then you have the parameter how you define the horizon, for example. And if you have a longer horizon, of course, the nesting efficiency can be a little bit higher, but then you have intermediate stocks. So it's always like a multi-dimensional optimization problem, and you have to decide on-site in your production system how much you want to emphasize having low stocks, for example, versus optimizing your sheets. But there are also companies out there that are heavily investing in these algorithmic approaches and include that into marketplaces, because sometimes maybe I, as one producer, does not have the part that fits in the inner contour of a part, then maybe on my marketplace there's another partner that has something that can fit in, and then you don't have wasted the inner contour, for example. So that's also some way to go in the future, but yeah.
Thank you very much for the questions. Please don't forget to rate the speakers in the app. Thank you very much for coming. That's for you.
Thanks.
So we have a 10-minute break to change room if you want or need to.